Okay, I think let's get going. Let's get going, actually. Okay, let me do this. Okay, welcome everyone to One Quantum Africa weekly meetings. And thank you very much for joining us. I know it's not an easy time, given that 3 p.m. is usually business hours here in Africa, but thank you very much for joining us even from across the world. Those who have got different time zones with us, we really appreciate it. I am Farai Majandu. I'm the president for One Quantum Africa. And One Quantum Africa is part of One Quantum, which is a global community, which brings people together to collaborate, learn, and exchange so that we can all succeed faster and we can build an industry that is fair and profitable for everyone. We've got other chapters, a startup chapter, we've got a women in quantum chapter. And our vision is to equip our members with the education and skills that's required to be successful in the field of quantum, as well as to connect them to the global community through events, summits, and also to support their growth through digital assets in mentorship, stipends, and scholarships. Feel free to reach out to me if you've got any suggestions on how we can make this community work for you. We're always willing to hear about what you're thinking about, to take ideas from the community so that we make it work for everyone. I will be talking about the meeting next week. Perhaps at the end of this meeting, I will share also the link for a cocktail that we usually host after our meetings to encourage one-on-one collaborations and interactions and to get our community closer together. We've got a special announcement for the Women in Quantum Summit that is coming early March. I'm going to share a link as Terrill presents so that you can register. We've got a special, this time around, we've got a career fair, and this gives you an opportunity to send us your CV, and we are going to make it available to companies in quantum that are hiring. So in case you want to pivot from where you are now to get into quantum, or you're somebody who's getting started in quantum, who's willing to learn about the opportunities that are there and wants to learn the different cultures of the companies that are sponsoring us, we are going to share those details as we go. Today, we are pleased to welcome Professor Terrill Frantz from Harrisburg University in the state of Pennsylvania in the US. He's an expert in quantum education and workforce development. He's been involved in this work. He actually pivoted from industry to come back into academia. And we are going to find out why. And we are also going to learn about what he is doing and the contributions that he's making. Most of you would know him through the meetup group for Philadelphia, Harrisburg Quantum Computing meetup. He's also very active in the community. You meet him at almost every meeting. I wonder how he manages that. I hope he shares his secrets. And he manages a platform that harmonizes all the events that are happening in quantum tech called the Quandama Palooza. Perhaps we'll also learn about what that means. And it's a bit of a tongue twister, but I know a lot of creativity went into coming up with such a beautiful name. Welcome, Professor Terrill Frantz, and we are happy to have you. I know that you've been so busy, but you gave us an opportunity to interact with you, and we really appreciate it. So you can come through. I'm going to exit this sharing of the screen and allow you to share your screen as well.
All right.
So let me do that.
Do your magic.
I do my magic. I give up my rights and I'm left with nothing. And you can take it away. Thank you very much.
All right. Let me just get the right thingamajiggy here. I guess I'll do a screen. There we go. All right. Well, thank you, Farai. Thanks for having me. It's always a treat to talk with the community, especially one that I'm not physically close to, but logically, I'm actually very close to Afrique and the countries and people in Africa to a more degree than you may think. But I'll explain what I mean later. But let me see here. I think you see something that says greetings from Harrisburg. So let me say hello from Harrisburg, Pennsylvania. And just to give you a sense of where I am physically, it's always a good thing for a mental model. The United States, North America, Pennsylvania here, and I'm in Harrisburg, and it's about a 2-hour drive from Harrisburg to New York City, to give you an idea. And right now it's summer there, as far I reminded me. Here it's -1 Celsius. We had snow 2 days ago. I guess about 2 inches. A snow squall just suddenly appeared. Anyway, greetings from Harrisburg, Pennsylvania. I also, I'm a professor, a faculty person at Harrisburg University, which is an unknown university. Even regionally, we're not very well known because it's relatively new by university standards, but we try to be a STEM focused university, and we're based in Harrisburg City. Harrisburg, by the way, is the capital of our state here. So we've had protests and all that kind of good stuff over the past year, a block away from me. I live right near the Capitol. But the school itself is around 7,000 students, mostly graduate level, master's degrees and PhD, mostly master's degrees. But we started our quantum journey in 2009, early in 2019. And presently, you know, we have programs in quantum computing or quantum technologies, or QIS, from high school to PhD level. So I'm quite proud of that because it's a small shop here when it comes to quantum. You know, it's what's going on here. We could be doing a lot more, and I'm working hard on that, but it's amazing to see what the influence of literally one individual can have, because quantum is really driven by one individual in a university, and I'm trying to create buzz and grab resources and so on. And you know, it's very nice to see some progress, not as much as you'd like, but you know, an individual can make some change and you know, take their idea and make it come to fruition. Again, it's not as far as I'd like, but you know, so be it. Today, while you're here, I'd like to just share things that I probably know more about than almost anybody, if not anybody, when in the quantum area, in the events going on globally in quantum space, which many of you are probably tuned into that, but maybe not to the depth that I've been focused in on that. I'll talk a bit about master's degrees that I maintain. I keep track of that in the quantum space. And the project I'm working on every day, well, all of these are every days, but the one where I'm spending a lot of time and energy in trying to get a handle on, and that is the job markets for quantum computing. So as I mentioned, I manage the Quantumapalooza site, which I'd like to walk through a little bit of with you today. I also have another site that maintains the master's degree information listed on the screen there. And the jobs is pretty much still private. I haven't figured out what and how to release that information to the public, but I'm all about, you know, making things available to people in our community. But let me just say, you know, for today, if you've got some question or comment, by all means, you know, put something in the chat, or if your microphones aren't able, just shout it out. I hate hearing myself talk, quite frankly. And students definitely, you know, I'm not an exciting speaker, I don't think. But let me just start with events, and I'll tell you. Yeah, let me just go with this slide first. First of all, well, let me give you a theme here. So the things I work on, the things I am focused on are the workforce development aspects of quantum. And why? Well, because when I first started getting into quantum, going to the conferences and talking to people, there were three big things, big issues that kept coming up when the experts who had been in this space for a while would talk. A, the technical aspects of error correction and noisiness in computing devices. Two was the algorithms. You know, the development of algorithms in the quantum computing space needs a lot of work there. And the third thing that people would consistently bring up across the board was workforce development. And so when I started this journey a few years ago, you know, you try to look where you can make an impact. And the workforce development one was an area that I thought we could make an impact, both in me personally and Harrisburg as an institution, because the others have very high expense. You know, it takes years to be a productive quantum engineer, et cetera. But workforce development, basically, in my opinion, just takes attention and energy to focus in on. So it's something that we could do. But I forgot to mention, though, I'm speaking of the continent of Africa and the community in Africa. I am quite passionate about what's going on there, as I am passionate about all countries in the world when it comes to quantum, frankly. But I've been studying Africa actually for many years. I visited Joburg back in, I don't know, it was 30 years ago, drove up to Pretoria. And I don't remember the name of the park, but I remember taking a small airplane. I got one of those tourist rides to fly over the park there and see all those mountains in that area of the world. And I'll never forget the song. I like to spend some time in Mozambique. It's a song called Mozambique by Bob Dylan. So I drove up to the border there, but I didn't go across the border because the border looked pretty rough at the time, so I decided not to cross over into Mozambique. I was only in Africa for like 3 days, but I also spend a part of my life studying China. I lived in China for 15 years, and one of the specialties I developed as a foreigner in China was China's relationship with Africa. And I study cross-border development from China. I teach a course in Denmark every summer on China cross-border development. And Africa is a big component of that. So the point is I do my best to try to maintain some sense of what's going on there, the activity, the entrepreneurial spirit in Joburg, for example, has caught my eye. So I do pay attention to what's going on out there. And I just really value the opportunity to talk with you folks. Those of you who are in Africa and elsewhere as well. I just got off a phone call with people in Australia this morning. Anyway, let me get back to where I was supposed to be going here. So when it comes to events, and this is one of them, around the world when it comes to quantum, there are about 63, counted 63 informal meetup type of organizations globally. And this is a number that's in flux. But to give you an idea, there are a few very, very large meetup groups in quantum, but it follows what's called the Pareto distribution, which is, you know, the normal social distribution, which means, you know, there are a small number of meetup groups that are very large and a large number that are actually quite small. So you know, that's something to keep in perspective. This group here, I would consider, you know, a meetup group, you know, and it's relatively small. And actually, in my opinion, I think when it comes to value add, it's the smaller meetup events like this here with the fewer number of participants, quite frankly, I think are the absolutely most valuable compared to these very large events, which are essentially broadcasts. And, you know, it's a pet peeve of mine. I want to see who's in the room, if you will, if we're going to form communities of people and engage people. We need to have small events. So many people really focus in on having as many people in the room as possible. I prefer, frankly, to be having smaller groups, much like this. So my meetups generally are 20, 25 people at the most. Sometimes, you know, they get large, but the best ones by far, the best experience for people are where, you know, people can inject their voice, quite frankly. But let me go through, let me show you the Quantumapalooza site here. That's some code there. Let me see what I got here. And I'm showing this not as an advertisement and all that kind of stuff, but I do want to make you aware of it because it is a tool that many people are using in their quantum journey, et cetera. And even and I find myself doing this if I have an hour in between a meeting or two or a break or whatever. I come to my own site to see what's going on in that hour, and if I can, you know, I'll attend that meeting. And they can be all around the world at all hours of the day. But anyway, I want to make you aware of the site. One feature here is that you can change the time zone, which will change all the various time zones for you, all the time information and date information for you according to where you are. So I think that's a huge thing. But what I'm doing in this site, besides providing, you know, tactical things of what's happening right now, I'm also working on gleaning information from this data. I mean, I think that's one of the things that Harrisburg can do as a small player in this space. We can collect data and turn that into information. So that's a theme of what I do. And here with Quantumapalooza, I've had the ability to maintain this site. It's probably been 10 months now, but I've got a tremendous amount of information on the types of activities going on, when activities are occurring, you know, what the seasonality of it, who's speaking at these events, who's producing the events, and all this sort of activity that, you know, when you think about it individually may not be, you know, it's a lot of noise, if you will, for lack of a better word. But when you aggregate this information up, this data up into information, you can get some really interesting stories. The most important thing is if someone were to ask, what is the growth of interest? What is the interest in quantum in the global community? You know, one metric could be the number of these type of meetup groups and presentations and so on. So that's one of the big things that I hope to be able to use this data to turn it into some information. And you'll see in the coming months, soon I'll start to parse this data out and go public with some of the stories. But, you know, one idea, there's 3.6 events per day, every day of the week. Going on, and that's a nice story. Now we'll see a year from now, there could be 5 or there could be 1 per day. We don't know, but we'll have some sort of metric to compare things to. For the past 2 months, I was getting a little worried. I stopped hosting events because I think there's actually too many of them, frankly, going on right now. And so back in late December and January, this past January, there were very few events. I mean, right now we have 51 of them scheduled for the future. Last spring, your time, you know, we were up in the 80s, 90s, and at one point it had 104 events scheduled for the future. So it got kind of slow during January and February. But this week, actually, it's really started to pick up to the point where yesterday I think there were 7 or 8 events in one day again, which is really an amazing number. And many of them happen at the same time, which really gets annoying. But even today, we got 1, 2, 3, 4, 5. So 5 events, and one was at 3 o'clock in the morning, my time. So there were 6 events today, just today alone, around the world. Tomorrow, 1, 2, 3, 4, 5. So 5 more tomorrow. 1, 2, 3, 4, 4 on Friday. So this is an interesting story going on. That's a lot of content. You know, here's the community, which you folks may be aware of, and so on. So it's quite an interesting story, and over time, I think this data will be a very valuable metric for assessing, you know, the growth of quantum computing. Remember, I'm focused on workforce development, and there's really 2 parts: supply and demand, right? So this is part of the supply side, if you will, or you could look at it as a demand story as well, too. So it's interesting. You know, I really don't have much more to say about that right now, but you know, putting this data together will tell some really interesting stories. You'll be able to also see, you know, what's the average lifetime of a meetup group, for example. You know, some of these are very active and then kind of drop off. Mine in particular, I actually have 8 meetup groups, and you know, I've dropped off all activity recently. So so that's interesting information if you're interested in workforce development. The second thing that I work on under the guise of workforce development is the master's programs. About a year ago, when I was attending events, business events, and academic events, all in quantum, the Quantum Economic Development Consortium, which is, we call it the QEDC here in the United States, for example, no one could answer how many master's degree programs there are in quantum. No one could answer that. It's a social phenomena. They basically, you know, took the universities that they knew and counted those universities, and they thought that was the population. And you know, being a scientist, that's hogwash. So I took it upon myself to get the answer to that. How many master degree programs are there in the world? And you know, it's actually a simple question, but I'm telling you, it took me 6, maybe 7 months of really a lot of energy and effort to really come to the conclusion, and with a high degree of let me get the site up here, with a high degree of confidence that we've identified all of the master's programs that have to do with quantum technology globally. And so I run a site called mastersdegrees.tryquantum.org that maintains this information. And I've been a little negligent on the look and feel. I'm not a look and feel guy. I worry when I put together websites and things like that. I'm more interested in its functionality and its utility and usefulness rather than its look and feel. So apologies for this. But anyway, it took me months to come up with the listing of the quantum related master's degree programs around the world. And there are 21 programs that I've talked to, all 21 program directors. They all know me. and we've all talked about their program, etc. So this is a list that I'll be drawing information from it, the types of programs, the growth of programs. I fully expect probably within the next couple of months, we'll start getting 5 or 6 announcements of new master's programs starting up probably in the fall. But having this data and turning it into information can start to help get into the business of predicting, et cetera. At the same time, helping the community out, because people, many are interested in getting a master's degree in quantum technologies. So what are the universities that have these degrees? What are the types of programs out there, et cetera? So right now I could tell you, look you straight in the eye and say there are 21 English speaking master's programs. I have some difficulty in places like Japan and Russia. And my friends in China are helpful, but with the language issues, it makes it a little bit more difficult to be sure. So I think the error is, I really think in Russia there are probably a couple of programs I haven't figured out yet, although I'm working on it. But anyway, so another metric in our workforce development is, and it's about supply and demand of talent, is the number of programs out there. Interestingly enough, one program is actually 11 years old. There's where is it? The University of Basque Country, which is northern part of Spain. Actually, their program has been in existence for 11 years, which shocks people. But they're definitely the first mover when it comes to a master's degree program in quantum technologies. The other last thing about this, the theme right now is that these programs are essentially quantum engineering oriented. Probably the second largest group would be quantum optics. So there's a lot of focus on engineering, as you would expect in an industry at this stage of the game, in this stage of development, on engineering. And so there are a lot of those coming up. Almost none of them, Harrisburg being one notable exception, is really coming from what you could consider computer science. So most, if not all, of the programs presently start from the physics departments, which gives you a hint that it's mostly physics oriented. And that kind of bleeds into the engineering notion. But when it comes to coming from the computing side, Harrisburg is really, fish out of water when it comes to that. That's starting to change, and I think that will start to change quickly over the next 2 years, that you'll start to see the computer science oriented programs starting to come out. But anyway, make you aware of this site if you want to do a master's degree. There are a few here that I'm still working on. It's a challenge trying to talk to these people. They're not quite as available as you may think. So there's still many on my list here that I need to work on, but right now I've confirmed 21 of them. So the third thing, which might even be more interesting because it's kind of where the tire hits the road, is the work I'm doing on jobs. So about a year ago, I started working with the Oak Ridge National Labs and their quantum newsletter, which is a weekly newsletter that goes out on quantum research. I started maintaining their job list for that newsletter. And so each week we list out the jobs in the quantum space. And me being a software guy, I don't like doing anything manually. So I started to write code to do this, create this list for me. Well, over the past 3 months, I've been really aggressive on this jobs project, to try to identify the quantum job market for real, not just based on a sampling of 1 or 2 companies, but really try to get to that 95, 98% mark of confidence so that I have the data. Much like I'm pretty confident events are pretty close, probably at around 95, 92% of the events going on. I know there's some others going on that but I just don't know where they are. Russia being a big area that it's very difficult. Master's degree, I have a pretty high confidence that I have most of the data, but when it comes to jobs, jobs are a far more difficult thing to a data set to build. But I'm making a huge amount of progress on it, and I'm feeling much better about where I am today than I was 2 months ago in trying to get to that point where you're really confident you have 90% of the jobs listed. Big holes are, as I was talking to folks in Australia this morning, Australia and certainly the whole continent of Africa, the numbers will be small, but every job matters to me. So I'll be working on that in the coming months, as well as you guys start to develop your ecosystem geographically there. So what I've been doing is searching for these jobs, building the infrastructure to maintain the listing of it. So let me be the first. You'll be the first to ever see this. This is still internal to me, but let me give you a sense of where we're at. This is a tool I have for myself to make sure the data is okay and all that goodness. But the way to look at that is that right now we have 275 institutions that have had a quantum job in the past, say 4 or 5 months. That's an interesting number. And presently there are 680 jobs globally in quantum. Now, let me just say, and this is a work in progress, what is a quantum job, right? That's a gray area. So, you got to be careful, guys like me, be careful when you're saying there's 680 jobs out there. I'll say there's 680 jobs that have something to do with quantum. We can talk about that if you have any questions. But so I'm maintaining this list, and this is a challenge. This list changes literally hourly. So keeping it fresh is a expensive challenge compute-wise, but doing my best to maintain it. So what you see is accurate information. What we can also glean from this is the activity for a given company. This case, Zapata being down at the end of the alphabet. Zapata has 7 jobs right now, and you can start to analyze what type of jobs they're offering. When they're offering, there is some seasonality to jobs in industry, at least in the United States, or any international corporation, I guess, for that matter. So what is that seasonality? Over time, we'll be able to answer questions. What's the job demand curve look like for a new startup in quantum? There's lots of quantum startups out there, and if I just go to I have it in alphabetical order here. So if I just look in the Q, P, Q, get my alphabet right, a lot of the startups start with Q something. And so, a lot of these small companies, here's a university in here, what's the trajectory, what's the typical workforce demand for these companies? Not based on somebody's guesstimate, but based on real hard data, much like the COVID thing, right? So what's the data really telling you? What are these job demand needs for these companies? what's how, if a company gets a $10 million investment from a VC firm, for example, what does that actually look like in the number of jobs that get created or demanded for various companies, et cetera? What are the number of jobs, right? What I was saying, there's 680 jobs in my database at the moment, changing by the day. I added one just a few minutes before we started today. Some of those jobs are pure quantum jobs. I mean, they're got quantum computing written all over it, for example. Other jobs say, well, we're looking for a computer scientist, and if he or she knows machine learning or quantum computing, we're interested. So is that a quantum job or not? That sort of thing gets really nuanced. So I'm building in the NLP tools to be able to classify these jobs in different categories. So that 680 number, will be ultimately broken out into, let's say, 100 high quality, meaning that they are pure quantum. That's all you're going to do, to something that may be a staffing position, right? So Zapata, as an example, hires, HR directors. Well, I consider an HR director at Zapata, I consider that a quantum job, but it would be a category that should be definitely separate from let's say, a quantum scientist or a quantum programmer. So that's the kind of fidelity when it comes to the data I'm working towards. We're not there yet, but that's the kind of stuff you'll see in the future. And this is really important stuff. From a tactical perspective, if you're looking for a job, for example, this is like gold. If you're an employer or a startup, you want to get a sense of what the competition looks like in the job market. And at the higher macro levels, what's the growth of this industry look like? What can we report a year from now to Washington, D.C. or Pretoria or whatever government, the EU, for example? We can actually provide this real, real scientific research data to these decision makers and policy makers and so on. So I'm pretty excited about this project because of the value I think it'll bring to the community. So let me get off the monologue here, and just return to this is what we're doing. This is what I'm doing here at Harrisburg in the workforce development space. Got other projects going on personally. I work with several standards groups, IEEE, ISO, on helping to work through what standards are on the technical side. But also I'm working on a IEC white paper with folks in Europe on quantum technologies, and working with ISO on putting together a terminology document that's being put together by China, Japan, United States, and the EU. So, I'm doing some other things, but these are the things that are, world unique and, that I have special insight to. There's 2 projects that are coming down the pike that once I get jobs stabilized, if you will, that I'm working on. One is really one of the big problems we have in our community right now is it's a great problem. There's so much video content out there. There's unbelievable amounts. And so I'm working on developing tools to be able to harness that wealth of information out there in the videos, in the recorded space, and be able to kind of put it together in some dynamic, customized way, so that you as a individual learning quantum computing, quantum technologies, etc., can go through an intelligent pathway to learn quantum. One that I don't design, one that's really algorithmically designed and personalized for the individual. So that's a project that certainly the second half of this year I'll be working on, which I'm hopeful will really, help out. Most of us are finding our own way when it comes to learning these technologies and such. And there's a lot of inefficiencies in the way we do it. That's one project. And the second project is start to really come across and be able to tell the story about national policies. I think there's a lot missing in understanding the national story going on in the various countries on their quantum investment at the national level. I firmly believe that we are entering a period of, like in the 1960s, most of you are probably too young for that, but in the 1960s, I was just a kid, a small kid at that point, but I do remember it. There was the race to the moon between the United States and the Soviet Union, or democracies versus the communist rule type of thing. And I think that national competition will be a major driver, mostly between the United States and China, but I think it's fair to say between the West and China. And that moon race to the moon to put a man on the moon, is taking the form of quantum technologies. So I firmly believe this next decade, having information about that game, it's kind of like a competition, that horse race between countries, I think will be really, really interesting and useful to know. So that's the next project that I'll be working on later on in the year. So let me get off the soapbox here and the monologue, and I hope there was some value in what I added, but in what I just gave. Certainly at a minimum, bookmark at least the Quantumapalooza site, and if you're interested in formal education, the Try Quantum site. So let me turn it over to you, Farai. I think I've kind of overextended my welcome on my monologue. Any comments, questions?
Thank you very much, Terrill. Thank you very much for the data and for the insights. It's something that is valuable and that we normally miss, and it gives us a good indication of where the field is going. And quantum is more about people, so if we know what kind of people are contributing, then it helps us to prepare.
That's well said. Well said.
Thank you for that. So yes, well, you can unmute yourself and come to the soapbox and ask as well. Ask Terrill. I think he created a lot of interesting points where we can ask questions as well. So yeah, you can unmute and come through.
Or what would be valuable to you? What kind of information? What kind of data? Sure. In your individual journeys might be useful. That's useful to me.
Okay, so while these people are coming through, let me ask you this, Terrill, because you've got a perspective to come from classical technology and how it unfolded, and also how quantum is unfolding. So when you look at it and the conversations we have had in China, the cross-border policy with Africa, and also looking at Africa in that whole space, what do you think is our competitive advantage as a continent?
Who is R? Who are you referring to?
Africa this time around.
So Africa has a lot of untapped energy, and I think that's like gold. And I suspect, I don't know the right word for it, but I think you have an opportunity to really focus, IBM is paying a lot of attention to South Africa, for example. I think I mean, let me just say what I'm doing, right? Okay, so when I started this Harrisburg thing, when I started my journey, I looked at it and said, what resources, what assets do I have? What assets do our university, does my university have? And really, you know, zero when it comes to, experience in physics. I think I took a physics undergrad, but I don't remember it. Maybe I learned about gravity. I come from the computer and business side of the house. So and you're competing against MIT and, as a figurative example, you're competing against people who've been in this space for decades. Farah, you've been here, almost 5 years now. So what do I have? What does Harrisburg have that others may be lacking, may not be interested in? That's what I'm doing. And I think and what I have that others don't have is energy and passion. And that's the key. And so I think what you guys have, as yourself and many of the others I've talked to from the continent, since we're talking about Africa, you've got that raw energy, and I think that's like gold. And you can steer that energy towards whatever direction you want, because this is the field is wide open when it comes to quantum. So, just look at what I'm doing, and that's the answer to that question. Because I've started from zero. Now I've got a lot of experience with classical computing, and I'm an old guy now, so that's been helpful in helping me think through that question that you asked. But that would be what I would say. You got a tremendous amount of energy, and I guess it's called kinetic energy. Is it potential? Yeah, it's potential energy, I think, in physics speak. That's worth everything, because when I'm in meetings with these these big, the White House group, the QEDC, the IEEE, with all, and it's not a criticism, but many of those folks that are in those meetings are burned out. They don't have any time. They're not as passionate as I feel they could be. It's just my personal opinion. Not to say there are differences, there are exceptions there. But the work I'm doing is an example that's driven totally by energy and a vision and passion. And that's what it takes to make a dent. And that's what you guys have, I think.
Thank you very much for that. Perhaps I can read the questions that are coming through the chats.
Oh yeah, okay. I can see the chat if you want me just to.
Sure, you can just pick them. Yeah.
Okay, all right. Hi guys. Okay, I scrolled from the top. A few questions. Microphone probably may have to. What don't we have to relearn as a quantum computing in Africa in terms of quantum? What don't we have to relearn? Something that others have already mastered. Well, let me just, that's the cool thing about quantum. There are no masters. No one's a master at this. So we all have something to offer. Even the big names are learning every day, and I just love it about this and about this technology, and that's huge. When I returned to the United States 3 years ago from China, I came from the business school, and I looked around the United States and said, what out of the tools I have and the interest I have, what's the most important thing? And I landed on cybersecurity. And so when I got back here, I started, figuring out where I'm going to land in cybersecurity. Where what niche do I want to work on? And I was in the IoT space for a while. I was thinking about, I'm really into disassembling stuff and all that. And where I'm going with this is that cybersecurity is extremely crowded. It's a big problem globally, but there's so many, it's got high demand, but there's so much supply. Everybody's doing it. People have been doing cybersecurity for 40 years, et cetera, et cetera. There are masters in that space that you can't compete with. It's just not going to happen. Quantum, there are no masters. So, you know, that's a question you need to ask yourself. And I would say whatever you decide to do, it boils down to having the energy to do it. So what advice can you offer to educators who might be interested in rolling out? Oh boy, this is a tough one. So Lorraine, this is a hard thing to do. In my trying to develop quantum for us, the harder part is internal to the organization, by far more complex than trying to make an impact to the community, and getting people's attention and awareness, and you know, and allowing classes to be held even if there's only 2 students. That internal battle is far harder than external, because externally, you know, it's like preaching to the choir. We're all quantum enthusiasts, so I don't need to try to tell you how important quantum might be in the future, but try convincing people that couldn't care less, don't even know what quantum is, that this is a big deal, or an important deal. I don't know how big it will be, but it's an important deal. So that's one of the reasons I put the Quantum Masters program, the Quantum Masters data together, is for people internally who want to start a program. The first thing you do when you go to your president or your dean or whatever, you have to give a competitive analysis. What are other people doing? So if you want to start a master's program now, you can definitively say there are 21 to 28 master's programs globally. So you can make the argument you'll be a first mover in this space. You know, it's early days, right? So that's I think that's the challenge, and everybody's challenge is different. When I talk to University of Rhode Island, for example, you know, that's driven by Zapata. Zapata's on the board of Rhode Island, you know, Chris at Zapata, and he gave money to start up a quantum program. So it was top down, money's there, you just got to execute. Most of us have to kind of scrape and put things together. So you know, what it requires is steadfastness there, because you're not going to, people are not going to be, you know, rolling out the red carpets for this stuff, although they should, but that's a challenge. One of the side projects with QEDC that I'm working on slightly, you know, it's kind of, when you work with a group, you can't move as fast. When you work as an individual like myself, you can move quick, is trying to put together a repository of syllabi for high school courses, which don't really have that sort of thing, but for university courses, because the next step when you want to put together a course, most people tend to kind of survey the landscape of what's being taught out there in other universities. What's the title of a course? So I'm hopeful, but it'll take a long time because it's a group of people, that we'll have a repository of courses that a potential teacher can start to draw on when they go to the administration and say, I'd like to have a course. You know, right now it's limited to, you can do a quick Google search and get some hits there. But I think, you know, if we're a little bit smarter about that data, it'll be much more informative and helpful to somebody who wants to get a program going. What advice would you give to last year university when like to shift to quantum computing? Look at that website, dude or dudette. Who's that? Esther. Oh, I've seen you before. Start with the website, because right there, those are the programs that have quantum, and figure out which ones are aligned with what you want to do. Now, quantum computing are very small. You know, University of Rhode Island's a brand new program, and I think they'll be leaning towards computing in the these are US schools. The European schools are almost exclusively the engineering and the physics side. So quantum computing, it depends what you mean. If you want to get on the algorithm development side of that, there really aren't that many hardly any programs yet. And there is some debate in the industry when I talk to other professors and other deans and program leads. Like the University of California system, for example, said, no, we're not going to do a master's program. We don't think that that a master's program in quantum computing is really something that people will be looking for. It's like saying their argument in their school, it's like saying, I want a master's degree in graphical processing units. If you think about that, if you look at quantum from that angle, do you need a whole master's degree in GPU, in how to write to a GPU? Now, quantum's a bit more complicated, but if you think about it from that perspective, and if you look at what AWS and Azure are trying to do, and startup companies are trying to do. Oh, by the way, I forgot to mention it. It's Amazon is the highest number of open jobs right now in quantum, by the way. Amazon. Honeywell is a close second. IBM, of course, is up there too. But anyway, so there is some debate, and it's logical. It kind of makes sense. Do you really want a master's degree in quantum computing? Right? I could make the argument a master's degree in mathematics is a heck of a lot more valuable, frankly, to somebody. So give that some thought, because there are some good arguments to say, well, it may not be the right thing, but a math major, that would be like gold for quantum computing. Are there some users MS quantum computing through online mode? That's exactly near job. That's exactly. I guess I need to read the question because you don't know what I read. Are there universities in the online mode? That's exactly what I'm trying to position Harrisburg University for, because my courses are online. And in fact, super early in discussions, what I'm thinking about doing at Harrisburg is actually getting a master's degree prep program put together. So for masters in quantum degrees. So one of the challenges we have in the education space is getting everybody, into a program with all the basics and all the fundamentals down pat. And so at Harris, this is really early, but I think it might work. What we'll be focusing on is making sure, linear algebra, just take the topic of linear algebra. Knowing how to do matrix math isn't going to cut it for quantum computing. You got to understand linear algebra to be able to put together algorithms, for example. So we're thinking through putting together like a college prep, a master's prep program that will prepare you for a big league master's degree in quantum technologies. B, it'll also really help your application, because the hardest part is getting into these programs because they're small. Most of them are small, some a couple like 100 or 2, but most of them are tiny. So the competition to get into these programs, especially these early days, is going to be pretty tough. So that's one thing that I'm thinking through right now, is putting together a prep program for that. But that would be online, and the Harrisburg courses are online, and we're just not, just haven't worked internally enough to be able to get that story out. But there are some of the programs do have individual courses online, but you have to be enrolled in the program. You can't take it. You can't just take one course like I'm trying to do here. Not to turn this into an advertisement. How can a university build a curriculum today and some of the challenges likely to face? So historically, the quantum programs are coming from physics, and I can see more recently engineering now. And I think the low-hanging fruit is coming from computer science. Because as a computer scientist, I look at things completely, I don't care about the physics. I really don't. I trust the engineers will get that to work like they've done with classical computing. So I think and I was talking to our department head of undergraduate here at the university yesterday, and we got one undergraduate course now, and he wants us to come back in the fall. I think computer science is the place that it should drive from. And if your computer science department has a history in high performance computing, HPC, even better, because they should understand the story. We okay on time here if I go over a minute or two?
Yeah, that's okay.
You got cocktails. I'm gonna have to pass on the cocktails. I don't enjoy drinking. I don't enjoy drinking anymore.
Virtual drinking is no harm.
It's not required, then I might hang out. Okay. I think I got them all. Thank you.
Sure. So thank you.
I will go to cocktail hour.
Thank you very much for that, Terrill. At least if you have time, it would be important perhaps for some of these people, they may have stories to talk to you directly on, and you can take that discussion forward. So thank you, Terrill, for coming through, and thanks everyone for the questions and for the commitment and for making this work. I shared the link on the cocktail, so let's catch up there, and let's keep on doing quantum. And I think we got a lot of encouragement from Terrill that we have to start where we are with what we have. So we don't need anything else. Thank you very much for that, Terrill.